Hi guys, welcome to my channel. In this video we will start talking about how to do FEA in Abaqus. The problem statement we are going to do is a bar under tensile load having a square cross section of 100 cross 100 mm and a length of the bar would be 500 mm. It will be fixed on the one end. Material of construction is steel, and then let's quickly start up the analysis in Abaqus. So first step would be to make the part. Before you make the part, just go and choose your working directory where you want to save your all files. So I have chosen it accordingly. After that, we'll quickly go for creation of the part. It's a simple bar. We'll go and we'll name it as bar. We'll use extrusion method. There we have a couple of options. As per your convenience, you can use it. And let's make the bar cross section. We'll just fix one end and then don't go for done. Now let's give the dimensions. 100 mm, 100 mm width. Cross section is ready. We can get out of here and then sketch the section for solid extrusion. How much we want? 500 mm. Once the part is ready, next section is to define a material. We will define our material. What we want to name it as steel. Steel. And then under mechanical we can define its elastic properties. Our material is isotropic. If you want to do composite materials, you have to go for lamina, orthotropic, or engineering constant. Now material is defined, steel material is defined. Now we need to make a section under section manager, steel section. And then once the steel section is defined, we have to assign this section to our part. So which part? Our bar. Steel section is assigned. Once the material is assigned to a part file, then its color automatically gets changed to green color like shown here in the video. So we have our part ready, we have material assigned to it. The next section we would like to do is meshing of this part. Okay, let's see how much is this. Okay, this is too less. Probably we'll go for 20. 20 is good enough. So mesh is ready. Now what we want to do is bring this part into assembly module. So if you have multiple components coming and gets assembled, then you have to bring all of them together and then import into assembly module and provide respective uh, contexts. But we have just one particular part here, so we need not to bother. So once we have the model in assembly, the next step would be what kind of analysis we want to do. That is defined under step module. So under step module, we'll go here, step section. Initial is there already. That's the initial state. And then now what kind of analysis we want to do. For example, static stress analysis. If you want to do some sort of buckling analysis, you have to come under procedure type linear perturbation and then choose buckling, or model analysis you want to do model frequencies under frequency. We just want to do a simple static analysis. Non-linear geometry off. We don't want to go into those details. So step is defined. Now we want to apply the loads. So as per our problem statement, we have one end fix, another end 1000 kilonewton load. How do we apply the point load here? To apply the point load, we need to first make an interaction between our surface and a point. What we want to do is we'll make a point here using this reference point. We know our dimensions are 100 cross 100, so we want to point at 50 cross 50. Once the point is here, we want to provide an interaction. We'll give a coupling between this surface and this control point. The control point is the point. Select the constraint control point. We have chosen the point, and constraint region type surface. We'll choose this surface. We want it to be constrained. We'll give a structural coupling here and provide an OK. So coupling is ready. Now we have to provide the load. So the load we have to provide is concentrated force. At this point, we will provide in Z direction as per the global coordinate system minus 1000 kilonewton to 3. Yes. Load is applied. Now only thing pending is the boundary condition. We'll just give Ancaster boundary condition on this surface. Model is ready. The last step would be to create the job, bar, tension. You can reduce the memory if you don't want your computer to hang. I'll just submit the job. Now the job is submitted. Once it is done, the status will change from running to completed. If there is any error, it will pop up as an error, and same can be seen here at the bottom as well. Or meanwhile, you can check under monitor whether it is done or not. Here it is done, completed. Let's quickly go to the results. So in results, we can see the stress of 104 megapascal. Similarly, you can look for the displacements in U3 direction. Directional displacements are also available. Directional stresses are also available. All 6. This can be observed. Nice. Okay, thank you guys.